SBAC review, simplifying, factoring, and solving equations. Hopefully this is mostly a review for most of you. The first thing that we're going to talk about is GCF. So the largest number and variables that divide into each of the given expressions. Okay? So 5x is correct. And we divide each of these by 5x, and when I do that, I'm left with 2x minus 11. Okay, and you can always double check what you've done is correct by redistributing through. Also, double check that when you do divide out that there is nothing more that I could have divided from these two that is the same. Is that? Okay, GCF. Whenever we're factoring, always check for GCF first. Okay. Next is difference of two squares. Okay, and you can read through this yourself here. But the first thing I check for is a GCF. And is there a GCF between these sets? No. And so then I try to write them as a square. So how could I write 9 as a square? 3 squared, right? 9 is 3 squared, and then we have x squared. And 49 as a square is? Very good. 7 squared and y squared. So here, everything is a square, and it's a difference. Remember that if this were, you guys, if these were adding, it wouldn't work. Okay? And so I just make my two sets of parentheses. Basically, we are like pulling apart each of the squares. And so a 3 goes in the front of each of them, and x goes in the front of them. When you get to the sign, what happens with the signs here? One gets a minus and one gets a plus. It doesn't matter which order. And then again, we'd split up the 7s and the y's. How could you double check that you factored this correctly?
Factor it out.
Yeah, multiply it out. Yeah, so you could either use your distributive property, your area model to multiply it out. Any questions? Okay, next we're going to talk about factoring trinomials. So that's when we have 3 terms. Okay? So remember that on these, we have our multiplication term, which is negative 30, and our adding term, which is 7. And so, oh, it's fine. You can just leave it. Thank you. We're looking for 2 numbers that multiply to be negative 30 and add to be 7. Good. You mean 10 and 3? Good. So 10 and negative 3. And so remember how we did the grouping method here? Have a good one. And we have 10x and negative 3x. It doesn't matter which order you put them in. And then we group the first 2 together, take out the GCF. The first group, this GCF is x, and we're left with x minus 3. The second group, we have a GCF of 10, and we're left with x minus 3. These should always match. And then now our GCF is x minus 3, and you're left with x plus 10 for your second parenthesis. There is a shortcut though, remember that if we do not have a coefficient in front, once you get those numbers, we can put them as our factors. And remember that whatever your first term is, you're splitting that in front of each of the parentheses. So if I had had x to the 4th here in the front, when you split that up, what would have been in each of the front of each of those parentheses? X squared. Okay, and so you always have to pay attention to what is there. So I'm going to give you a minute. You're going to factor this one on your own. You were supposed to do unit 7 for Friday. Friday. And then this so each day I'm assigning you 1. And then I have both last times and this time's answers right. Okay.
Yeah. Thank you.
Uh-huh. Okay, so what's your multiplying term? Your multiplying term is 24. And your adding term is negative 10. So what numbers will work? Very good. Negative 6 and negative 4. So do we want to use this same process here or a shortcut? Okay, does anybody want to do the whole long method? Yes? Okay, I'm going to go into the long method for those that want it. So we would rewrite this out as x to the 4th. Because this is a negative 10x squared, you would be changing the negative 10x squared to be negative 6x squared and negative 4x squared, because these two need to add to be this. Okay? So negative 6x squared and negative 4x squared. Whatever that middle term is, like in terms of the x's there, that's what that becomes, plus 24. Now that you have 4 terms, we would factor by grouping, and so we would separate our first 2 terms and our last 2 terms. What is the GCF of the first 2 terms? X squared. And when you do that, you're dividing each of these by x squared, and what are you left with? Good, x squared minus 6. The GCF of the second group is what? A negative 4. And you divide each of these by negative 4, and what are you left with? X squared minus 6, because a positive divided by a negative is a negative. These should match. If they don't match, you did something wrong. Okay? And so now our GCF is x squared minus 6, so we factor out x squared minus 6, and we're left with x squared minus 4. Okay, the short way would also work on this one because there wasn't a coefficient in front. Now, you need to check if you can factor further. Can I factor either one of these further?
Yes.
Which one?
X squared minus 4.
Good, x squared minus 4, because that is a difference of squares. This is x squared minus 2 squared. So when we factor that, we solve our x squared minus 6, and then we factor these and it becomes what? We split up our squares and we get x minus 2 and an x plus 2. And again, the order of your parentheses does not matter. Any questions? Okay, let's move on. So we have more factoring by grouping when we have 4 terms. So again, when you have 4 terms, we break the 4 terms into 2 terms, or 2 groups. This one, the GCF of the first group is x, and you're left with a plus b. The GCF of this group is a y, you're left with a plus b. These should always match our parentheses, and we end up with a plus b times x plus y. Okay, I'm going to give you a minute over here, but before you just break these up, and I forgot to say it over here, what should you always check for first? Very good. Your GCF. So anytime you're factoring, always check for your GCF first. And so hopefully as you go through there, you notice that there actually is a GCF there. So do that and then factor further. What did you guys end up getting for your GCF? 4W. So I always look through at the numbers first, and 4 is divisible into each of the numbers. then this has 3 W's, 2 W's, 2 W's, 1 W. So I know I can take out a W. I don't even need to look at the Z's because see how this one doesn't have a Z? I can't take out a Z. So I start by taking my GCF out, which is 4W. And I like to go through and write that underneath every term because it's easier for me to see how it reduces when I have it written. So on this first term, what am I left with? W squared, good. Because the 4's cancel out and then we reduce the W's. What happens on the second one? WZ, good. And then plus 3W, and then last one, minus 3Z. Do we have any questions on that part? Okay, so now I have 4 terms, which means I'm going to break them up into 2 groups. And then now we are just dealing with factoring this. The 4W is still part of my answer, but I need to factor this out. So what's my GCF of this group? W, and I'm left with W minus Z. What's the GCF of the second group? 3, and I'm left with. And so therefore, my GCF of the whole problem here now is W minus Z, and I'm left with W plus 3. And then don't forget that you have to bring down your 4W. And so this is my final answer. Remember that if you were to re-multiply this out, it should go back to the original problem. Okay? If you left off that 4W, it wouldn't multiply out to be the correct problem. Okay. Do we have questions? Okay. Moving on. So, do you guys remember factoring sum and differences of cubes? Okay, so I have this, bless you, written out here. So with cubes, with squares, they have to be a difference of squares in order to factor them. With cubes, it can be sum or difference of cubes. So you always want to make sure that you write the terms, each of them as cubes, before you factor them out. And then remember SOAP, where this is standing for the same sign as your original problem, opposite sign of the original problem, and the last one is always positive. Okay, let's do this one together, and then you guys can try the differences of cubes on your own. Does that sound good? Okay, so the first thing we want to do is write every single term as a cube. How can I write 8 as a cube? Okay, so this is 2 cubed and x cubed plus, and 125 is 5 cubed. The next thing that we did in order to help us with this is, well, there was 2 different ways that we did it. One way is that this really is saying 2x cubed. That whole piece goes together. Your first parenthesis is always whatever it is as your cube. Like this is just your first parenthesis, you just take away the cube. Oh my goodness, that's supposed to be 2x. Okay, so we get 2x plus 5. That's my first parenthesis. So all I did was take off the cubes, and this was my first parenthesis. Everybody good there? And then the other parenthesis is where I had you guys write it out. So 2x cubed means you have 3 2x's. 5 cubed means you have 3 5s. And then you group them. So your first term in your second parenthesis is those multiplied together, which makes what? 4x squared. Your next term is those multiplied together, which makes 10x. And your last term is those multiplied together, which makes 25. And then using SOAP, first term, always the same. Second term is the opposite, which would make it a minus. And the last one is always positive. Now, another way that I talked through this, so this was one way to factor it, was you have your first parenthesis that's made, and then The first term here is this first term squared. So 2x squared makes 4x squared. The last term is the last term squared. And 5 squared is 25. And your middle term is these multiplied together. And 2x times 5x makes your 10x. And then you still use SOAP. So either way you want to think about that, you can factor either way, and that's your answer. So now you're going to try this next one on your own. How do we write 1,000 as a cube? Okay, and then we're going to put these together as a cube. So I'm going to write that as xy cubed. How will I write my first parenthesis? That's it, 10 minus xy. All we do is take off those cubes. Do you guys like it written out this way or the other way better? Written out? So that means we would write out 10 times 10 times 10, and then xy times xy times xy. And then you group them in twos or pairs. Okay, so the first term ends up being what? 100. And then 10 times xy is 10xy. And then the last term will end up being what? You could do it as xy squared, or you could have it as x squared y squared. Either way will work. And then how do these signs go? Both of those are positives. Another thing to remember is if you look at the factored form of each of these, how many negatives are in it? 1. How many negatives are in this one? 1. So you should only have 1 negative when you factor them using either method. Okay. Any questions before moving on? Okay. So you have this next one. You need to factor it. Looking at that, what do you notice about this problem? What should we always check for first? GCF. Do we see a GCF in this problem? Good. There is a GCF in this problem. What is it? GCF. This has a y plus 2 and this has a y plus 2. That's our GCF. Okay. So we're going to factor out the parenthesis y plus 2. Just like when we're factoring and we want our two parentheses to be the same, so we can take, that's what exactly, they just have done it for you first here. So when you divide this by y plus 2 and this one by y plus 2, what do you end up having left? Yep, so I'm going to make this as a bracket because I have left y plus 2, because when you divide the squared by the y plus 2, this one, okay, minus, and then on this one, these cancel out and you're left with y plus 3. And I should have a parenthesis there. Okay, and so you will see some answers like this on your test where you're factoring out your y plus 2. Yes? Why did I use the brackets? The only reason why I used the brackets is because I knew I had parentheses, and so I just wanted something different. Oh, okay. You could have had parentheses as well. Kind of like separate them? Yeah. Okay. Next one. It says choose from the instructions below and place something in the box to create an equation that is true for all the values of x. And it says assume no denominator will equal 0. Okay, so looking here, what would be your common denominator for this problem? So we have an x plus 2, and we have an x, and we have an x squared. Remember that anything with a plus or a minus is stuck together like glue. Okay? And so for your common denominator, we need an x squared because the x squared and the x, that will work. So you have to have at least x squared because of this. And then we also need what? X plus 2. Once you figure out your common denominator, then you go to each of these terms and figure out what is it missing. So this already has the x plus 2. What is it missing? X squared. So we'd have to multiply the top and the bottom by x squared to get our common denominator. Do you see how they already have the 5 written here? So what would I need in this box? X squared. Okay, for the 4, there's only an x here. So what am I missing? What do I still need? Good, an x and an x plus 2 is what we'd have to multiply the top and the bottom by. So the 4 is already here. You would need an x and an x plus 2. And then the last one, what is it missing? Just the x plus 2. And that's it. That would be your answer. Okay, multiply and combine like terms. This one, they just have it written weird. But anytime you have parentheses and then like a letter next to each other, what do? What does it mean? If I have this, what does it mean? Distribute. It's multiplying, right? So on this one, we have the z. It doesn't matter where you distribute it to, but this z needs to be just multiplied to one of your parentheses. Okay? It can only go through one of them. So I'm going to distribute the z through here. When I do that, what do I get? 2yz plus 3z. Okay? And then that now is multiplying by 5y minus 2. You can use your area model method, or you can use your distributive method. It's up to you. How many of you like to just distribute? How many of you like the area model? How many of you have no idea what I'm talking about? Okay, this is not good. Okay, so your area model is like this. Since these are 2 terms by 2 terms, this would be 2yz and 3z, and this would be 5y minus 2, and we multiply to get each of these boxes and combine like terms if we can. Distributive method, we multiply through like this. 2yz times 5y would make, very good, 10y squared z. 2yz times negative 2 makes negative 4yz. Good. 3z times 5y makes 15yz. And then 3z times negative 2 makes negative 6z. Are any of these like terms? Yeah, do you see how both this one and this one are yz? So we can add them together and we end up with 10y squared z. Negative 4 and positive 15 makes how much? Positive 11 yz, and then minus 6z. Okay, do we have any questions? Okay, so combine or multiply and combine like terms and reduce. Before you start here, do you notice any way we could reduce this? Yeah, 2 can go into 6, right? And so 2 would cancel out and 6 would become a 3. And since they want us to multiply, we're going to go ahead and distribute and multiply this all out. Okay, so this is just like distributing on this last problem or using your area model. So I'm going to give you a minute to multiply that one out. So here when we multiply, y times 4y is, y times 1 is, and then we go 3 times 4y, which is 12y, and 3 times 1 makes 3. We have like terms there. We end up with 4y squared plus 13y plus 3 divided by 3. And that's your answer. Can I reduce this 3 and this 3? No. Why not? Remember that, yep, anything that's adding and subtracting that is all stuck together like glue, and the only way you can reduce it is if it's exactly the same. Okay, moving on. Okay, choose from the numbers below and place the correct number in that little box. Okay, so we are trying to make each side equal. What are we going to have to do? Very good. Simplify the left side to see what's missing. How do we simplify the left side? What am I going to have to do? This you have to multiply out. Remember that anytime you have something with a plus or a minus, in order to multiply it out, you have to write it out twice and use distributive property or distributive method or your area model. When I multiply this one out though, what does it become? X squared minus 14x plus 49. So remember that these two numbers add to make your middle term, and they multiply to make your end term. And that would be your shortcut if you wanted to, or you can just distribute and find your like terms or combine like terms. And then I saw plus 51. What is 51 plus 49? Plus 100. So what is missing? So based on this, we are just missing a negative 14 there. So that is what I would choose to put in there. Any questions? Okay. Four equivalent equations for f of x are shown below. Select the form that reveals the value of f of x when x equals 0 without changing the form of the equation. What does x equals 0 mean? What are they talking about? It's talking about your x-intercepts, okay? When would the graph cross the x-axis? So which form would you use to find those values? You would want to find the ones where it's factored, where you could easily set each of the factors equal to 0 and then be able to plot them on the graph. So which one has it written that way? A. And then what would be the solutions for x on those equations? Very good. X would equal 5 and x would equal 9. Just out of curiosity, which one of these would tell you the vertex without changing the form? D is correct. Okay? Your vertex is always your maximum or minimum value. Okay? In what direction would this graph be going? Down. How do we know it's going down? The A value is negative. Okay? Which means, is it a maximum or a minimum? Maximum. Because everything else is less. Okay. All right. Oh. Okay, I just gave you all the answers to this one. So which one is the correct answer? D. Okay, and it says, is it a maximum or minimum? You guys just told me. It is a maximum. Do you know what the maximum value is? So the vertex would be at 7 up 12. But in terms of, let's just pretend like, okay, so this is 7, this is 12. I know it's not a very accurate graph here. But 12 is your maximum value. Wherever the y is, that is your maximum. Okay. So, and then it says, what is the vertex? Good, 7, 12. And then our last one asks us to factor and solve for x, your real and imaginary values. Okay, what do we always check for first? GCF. Is there a GCF? No. So if you look through here, they don't all have x's, they don't all have 9's. So we just factor by grouping because I have 4 terms. Now, what is the GCF of the first group? X squared, and we're left with?
X plus 1.
Good. What's the GCF of the second group?
9.
And we're left with?
X plus 1.
And this then factors to be?
X plus 1.
X plus 1 and?
X squared plus 9.
And x squared plus 9. Okay? Now, once you factor this, when they want us to solve for x, that means we're setting all of this equal to 0, which means you are setting each of these factors equal to 0. So when I set x plus 1 equal to 0, what answer do I get for x? -1. When you set this equal to 0, x squared plus 9 equals 0, what do we do to solve that? Subtract 9. X squared equals -9, and then what would you do? Take the square root of both sides. Anytime you take the square root, remember this becomes the absolute value of x equals, and you have to take the negative out, which makes it an I, and then the square root of 9 is what? So the absolute value of x equals 3i. Well, what does that mean if it's absolute value? X can actually equal positive or negative 3i. Okay, so we have these solutions and this solution. How many real solutions do I have? 1. How many imaginary solutions do I have? 2, because we have positive and negative 3i.